Hello, class 12th physics, chapter EMI, important questions, part 2. Two spherical bobs, one metallic, other of glass, dropped from same height, which would reach the Earth's surface earlier. Why? Remember one thing, their fall will not depend upon their size, because acceleration due to gravity on both is same. So, what is the point here? Well, actually, Earth has its magnetic field. Well, this question is pretty hypothetical because whatever they are trying in this question is not that practically observable. But theoretically, one will reach the Earth little later. How? The answer is due to Earth's magnetic field. There will be a change in magnetic flux in the metallic sphere. So, eddy currents will be produced which opposes the relative motion and slows it down, but not in glass bob. So it will reach, it means glass bob will the Earth early. A metallic piece gets hot when surrounded by coil carrying high frequency AC. Why? High frequency AC produces varying magnetic field which induces eddy current. Which causes heat. And you can give this formula also. Okay, a long straight current carrying wire passes normally through a center of a circular conducting loop. If current is increasing, will there be induced current in the loop? Justify. This is a long straight current passes normally through the center of circular conducting loop. Here it is, that loop. If current is increasing, will there be an induced current in the loop? This is the loop. Will there be an induced current? So, answer is no. The reason is magnetic field produced by this wire will be in the plane of the coil. Magnetic field produced by the wire lies in the plane of coil. So, no field line passes or crosses the loop. So, there is zero flux and no change either. So actually it is increasing this way, like this is the conductor and this is the plane. So if it's magnetic field, so it is increasing in this plane. So like this is the loop and continuously increasing current is increasing in this wire, and there is conducting loop. So magnetic field will go like this in the plane same as the plane of this loop, and so flux is zero. And if magnetic field line are also getting stronger and stronger, but no line is crossing the loop, so that is why there will be no flux change, and hence there will be no induced EMF or induced current. So there will be no induced EMF and current. And to support your answer, you can write E equal to d phi by dt within mod. Next, a coil Q is connected to a low voltage bulb and placed near another coil. Okay, there are two coils. One is connected to AC source. Give reason why bulb B lights. So first thing, actually P is connected to AC source. So flux changes in it, and since Q is coupled, actually it is is close to this, so we call it coupling. So it is coupled with Q. Q is coupled with P. So flux changes through it also, which produces EMF. Oh. And bulb glows. Second, B get dimmer when Q is moved away. So case 2, when moved away, B decreases. So when moved away, B decreases, so rate of change of flux also decreases, and hence EMF, that is d phi by dt, decreases, so B gets dimmer. Next, two identical loops, copper and aluminium, are rotated with same angular speed in the same magnetic field B. Compare induced EMF. So, since E is equal to d phi by dt and d phi by dt, okay, loop, so d phi by dt only. Why I put this mod? Just to avoid writing that minus sign. Since E is independent, nature of conductors, nature of material of conductors, so E through copper ratio, E through aluminium is equal to 1:1. Both will be same. Yeah, there is a term that both are moving with same angular speed. So we can also explain that here, that if we want to explain the angular velocity term, then E is equal to E naught sine omega t. It comes after this. If you put the value of phi, then this can be derived. Now see, since omega is same, so E is same for both loops. All right, next, current produced. So ICU by IAL is equal to I equal to E upon R. ECU upon RCU. Both are identical loops. EAL by RAL. So that will be equal to, actually both are the same EMF, so they will cancel out. So RAL upon RCU. And R is rho L upon A. L and A will get cancelled, so rho for aluminium upon rho for copper. And we know that resistivity of aluminium is greater than resistivity of copper, so it is greater than 1. We know about it. So that's why we can say I through copper is greater than I through aluminium. If you don't want to go through this reasoning, you can directly say that since copper has less resistivity than aluminium, so it will draw more current. And directly you can write ICU is greater than I aluminium. A current is induced in C1 due to the motion of C2. Okay. So here it is connected to some battery and some current is flowing through this coil. So it will producing magnetic field. And this time we are not decreasing current from here. We are moving it. So if we move it, there will be an induced EMF, that's for sure. Write any two ways by which larger deflection can be obtained in galvanometer. So first way, by increasing speed. Second thing, I mean, I have written very short way, increasing speed of C2, if we move it faster, then second thing can be by increasing current in C2. I increased in C2. Anything else can be done? Yeah, if we move both of them toward each other, or yeah, that only. Because if we move both of them away from each other, magnetic field will decrease and the effect of larger deflection will not be obtained. So third case can be moving both of them toward each other. Okay, B part is suggest alternative device to replace galvanometer here with valid reasoning. Okay, so what else we can connect here? So we can put a compass needle, magnetic compass, or a buzzer, or an LED of low voltage requirement, means which can run on low voltages, because it is not a very big EMF here. A magnet is quickly moved in the direction of arrow. Oh, I haven't drawn the direction of arrow. Let us suppose it is this, C1 and C2. What will be the direction of induced current in each coil as seen from the magnet? So from here you are seeing it, and one time you are seeing this way, other time you are seeing in that way. All right, explain your answers. So first thing, for this is C1, this is C2. For C1, magnetic north is moved towards C1. According to Lenge's law, it will induce north pole in it. So direction of current, north, anti-clockwise. C2, magnetic south is moved away of C2. Now, according to Lenge's law, it will induce, now what will happen? It will try to repel it, induce, no sorry, it is moving away, so it will try to attract it. So that will be, it will be induced north pole. So direction of current, again anti-clockwise. So in both cases there will be anti-clockwise current. Here it will form induced north pole, so direction of current will be anti-clockwise, and here it will try to attract that, it will form north pole here, so direction of current will be anti-clockwise again. Show that magnetic energy required to build up current I in a coil of self-inductance L is this. So that energy should be written as U. Why not E? It looks like induced EMF. So that will be equal to integration E dq. Well. Actually, we know that V, potential difference, is equal to W upon Q, or some energy upon Q. So U equal to VQ. Here, instead of V, we are using EMF, E dq. And that will be equal to E dq is E d at I dt. And what is E? E is here, for inductor it is L di by dt. I am ignoring negative sign, you can also do that. L di by dt, I dt. dt will get cancelled. Why I ignore that negative sign? Because when it is not in comparison to any other, then we should ignore it. But if there are two EMFs or more EMFs, then if we have to just compare between them, then we have to include that negative sign also. Now that is L I di, integration will be I square by 2. So it will be half L I square. And remember that the same type of derivation is for that capacitor also. Okay, there is, they didn't ask the question, but I'm including that here, energy density. If they would ask energy density, so that will be equal to energy density inside a solenoid or in a magnetic field, uniform magnetic field. Okay, so that will be U upon volume, A into L. So U is half Li square upon area of coil. I'm writing A, and length is as L. Now what is self-inductance of a solenoid? It is half mu naught N square Al and C. That's interesting. Al will get cancelled. It will be half mu naught N square I square. Why not this? And this is the magnetic field produced by a solenoid. So we can write it half, in fact, this, and B square here. Remember, for capacitor, energy is half CV square, and energy density is half epsilon naught E square. Okay, now in the adjacent diagram, D is this much, L is this much, centimeter or meter, I don't know, maybe centimeter. V 20 meter per second, resistance 0.2 ohm. Find induced EMF, very easy, E equal to BVL. V is 0.1, V is 20, L is 10 centimeters, that is 0.1, so it is 0.2 volt. Induced current, I equal to E upon R, like V upon R. So here we have E, R is 0.2, there will be 1 ampere. Force required to maintain constant velocity. Actually, when we push it this way, there is induced current in it, going upward. So induced current is going upward like this, magnetic field inside, so it will experience magnetic force that way, opposite to the velocity. So we require some external force to pull it against the magnetic force, and that F will be given by BIL. So that's so simple. B is 0.1, I is 1, L is 0.1, so that will be 0.01 Newton. They didn't ask it, but I am telling you it will be toward right. Rate of dissipation of energy. They are not asking about energy. Rate of dissipation of energy means power. So that's so simple. Power equal to EMF into current. So 0.2 into 1, that is 0.2 watt. That's all. Next, find induced EMF in a rod of length L. So now see here, there is a conducting wire frame, and there is a slider, and we are pulling it this way. So there is a magnetic field, and that slider is pulled. So there is a conducting path. It is a conducting wire, and this slider is also conducting, ensuring that there will be a closed circuit, so that you can easily understand that how current is flowing here. So for the sake of simplicity, just imagine that positive charge flows. It will make the thing easier. So now, actually we are pulling rod this way. It means we are pulling all the positive charges along this direction with constant velocity V. So it means when we are pulling it toward this, we are pulling positive charges, so they will experience force in upward direction. They are experiencing force in upward direction. So all the positive charges will move in upward direction, and there will be an induced EMF. So that induced EMF E will be d phi by dt. And what is this d phi? Is dA, d of dA by dt. And what is this BA? Well, I don't know what is this happening. Okay, I'm removing this. It means I'm just working on the numeric part, not the sign. So dA by dt. And what is dA here? dA is, okay. Its length is L, and from here to here it is x, dx in fact. So dA will be L dx by dt. And what is dx by dt is V. BL V. That's all. However, there are some other questions like force. So we discussed here. So force will be BIL, and I we can obtain from here. It is induced EMF. So current will be E by R, and then we can put it here. Power we can put it here. I told you that why force is there, because actually all the positive charges are moving up. And again, for the sake of simplicity, I am considering that positive charge move. I can say that electron will experience force, they will be moved according to this law, but we have to change the direction of thumb downward because electrons are negatively charged, so electrons are going downward, so this end is negative. Now electrons are going downward, so current is going upward. So I'm removing all that confusion, and I'm considering that positive charge is moving. That's all. Positive charge is moving, so current is moving up. So now see that current is going up in this magnetic field. So if current is going up, then see this condition in a different perspective. Current is going up and magnetic field is inward. So this wire will experience force toward left against the velocity, opposite to the velocity. So we have to maintain this velocity by pulling it with equal force. That is pulling it backward. So that force will be DIL. Well, it is not asked here, but I am guiding you about that. Now it is rotating. Oh my god. So if there is a rod and which is rotating in a circle, that will be fine. So it has moved d theta angle OAB. L is the length of the rod, and let us suppose it is rotating with angular speed omega. So once again, E equal to d phi by dt, and this is d dA by dt, and which is b dA by dt. But area will be half into base into height. Half into base is OA into height is, well, this angle is not so large, so this arc can be taken as height AB upon dt. So half into OA is L. AB, arc, angle equal to arc upon radius, arc equal to angle into radius. So angle into radius upon dt. So d theta by dt is what? That is angular velocity. So half L square omega. Where is B? Where is the B? Oh, I missed that out. B. Without B there will be nothing. This is the final formula. I have to write it in a proper manner. So it will be half B L square omega. That's all. That's all in this video. See you in the next video on AC.